Great, thank you. Welcome, everyone. Please take a seat. So, all right. So in early 2008, we sent out a survey looking at the landscape of what Ingress was to fulfill. This was a survey from the users to say, hey, what features are you getting out of Ingress? What features do you consider important? And basically, Ingress describes an L7 proxy-based load balancer. Of course, it could be extended to L4, but L7 is the domain it serves right now. Now, in our mind, when we looked at what is the next Ingress API, actually there were a couple of meta questions that we also were asking. Does it make sense to be part of core Kubernetes? Could there be a project that's actually outside of Kubernetes that we can point to and say, hey, use that, because that has already solved the problem? The other aspect that we considered is, could we have a stronger statement on portability and feature sets? For example, one option would be to say, it's not portable. We can't reconcile all these different providers. Let's just give up on portability. Another option would be, let's standardize on a given implementation and wait for everyone to converge. Now, looking at this, in terms of the landscape of actual implementations, we have both the cloud providers providing proxy infrastructure, as well as sort of off-the-shelf user space proxies. And it looks like it's likely infeasible for clouds to allow the kind of customization and expressiveness of a self-managed proxy. But we do see convergence, but it's slow. And finally, in this space in the past 2 years, we have basically the rise of the service mesh. So this is a third player in the space of L7 load balancing. Now, in terms of asking this question, it is important to look at sort of existing models. So we have this challenge in the Ingress API of portability, expressiveness, and features. But in the past 2 years, also, we have seen a lot of APIs try to fill this space. And one thing to ask is, what can we learn from each of these APIs? So I'm going to go through a couple of popular models. Now, I reference these systems. It's not for illustrative purposes. It's not meant to be exhaustive. So if you don't see your favorite system here, it's not mean it's not cool. It's just I didn't put it in the slides. OK, so what I'm going to do is decompose each of these models into key attributes. I know there are not a lot of nuances to the APIs, such as the features supported and the specific way you write them. But for the purposes of this representation, we're going to look at the big picture, right? And here we have the good old Ingress resource model. We have a single resource that describes a bunch of host path matching, and it goes to backends. And the key attributes for this is that, one, it's self-service. So a single developer can define and configure all aspects of the front end, TLS configuration, and the back end at the same time. It supports a single role, which is the developer kind of owns the whole thing. And it's very simple. It's just one resource to understand. Now, as part of the GA work, so that was the beta, as part of the GA work, we have kind of codified certain common practice and also added a little bit of flexibility. So we've added this notion of an Ingress class. It's very similar to that of a storage class, in that you can say, hey, this is my Nginx Ingress, or my HA proxy Ingress, or my cloud Ingress. And also, we're currently in discussion, although this may be punted, to add more flexibility on the back-end side. So if you imagine assembling your load balancer, you would probably want to assemble things other than services into your load balancer. Another popular model that has come up in the past 2 years is that of Istio. So Istio is a service mesh, but really the set of resources it uses is also intended to serve traffic ingress. So what are the key attributes of Istio? Well, one big difference is that they have separated the representation of the proxy infrastructure from the rest of the application description. So you have this gateway that describes the proxy infrastructure. Then you have virtual service and destination rule that describe how the application routing works. And then finally, we come back to the services at the other end. So the key aspects of Istio is that it actually supports separate roles for proxy infrastructure in application description. And then it also has a very rich feature set, which is primarily based on Envoy. Another model that has come about in the past 2 years is that of IngressRoute. So IngressRoute is an interesting API model in that it is recursive. So you have this single resource IngressRoute, but IngressRoutes can connect to other IngressRoutes. What this connection means is a delegation. So you'll see here the red IngressRoute has rules for just the top-level hosts, but the delegated IngressRoute has rules for a specific host in a specific path. So this lets you model separate roles, and it has this recursive composability feature. Of course, in addition, it has added some features such as traffic splitting, among other things. Now, there's lots of other API models. Just for completeness, we note that, of course, everyone adds lots of annotations for describing their features. And some implementations have actually implemented Ingress-like features using decorators on service and then merging it post facto. And also, you can just go straight to custom resources. So the question is, what have we learned? So when Ingress was first designed, the focus was on simplicity and a single developer. But really, when we're looking at kind of what these APIs are trying to solve, we see that we need to handle multi-role environments. For example, you have infrastructure, people working on infrastructure, providing Ingress as a service to the application developer. And you may not want the application developer to own everything. The second thing is this question of how much portability. So if you look at the results of the survey, there's a very paradoxical desire to both have portability yet not prevent the user from using all the capabilities if they so desire. So in some sense, we need to design the API such that this can be a user choice, right? We can't, the worst thing to do is to tell your user, hey, you can't use this, it's not portable, but they know they want to use it. Finally, just in general, we should change the syntax a little bit to support future API growth. So while there are gaps today, the claim is that in the future, providers and features will converge. And we do see convergence. For example, the cloud infrastructure is slowly adding all the features that the user space proxies already have. Now, given all that, this is a modest proposal. Warning, this is super early. This is basically a shot in the dark. So we really want a lot of feedback from the community. And the thing to note is that this takes heavily from existing work. So we don't aim to try to be clever and solve it a different way. If an existing model works well, then we should actually adopt it to be the standard for Kubernetes. Now, the way I'm going to sketch this is first, I'm going to talk about the shape of resources, basically the model that we are thinking about. Then I'm going to talk about portability and extensibility, how to make that a first-class feature of the API. And then finally, we will discuss future directions, and one of them would be multi-cluster. So in terms of the model, this is nothing earth-shattering, right? We need to model the infrastructure, which is the load balancing implementation, separate it from the application description, and of course, we have the backends in Kubernetes today. Now, to anchor this discussion, we have basically a straw man set of resources. We take from the Istio model this nice feature of representing the gateway or the proxy infrastructure as a resource itself. And we add on to that a notion of class. So you can imagine that today we have Ingress class and Ingress resources. You have something similar representing your proxy infrastructure. You may have a gateway class that represents your Nginx and another gateway class that represents your cloud infrastructure, and then you can create gateways from there. In the middle, you have a virtual host. Now, a virtual host may be recursive, like IngressRoute, and this is your application description. So this is what your application developer will write to describe their application routing, and then it may be delegated to support the different roles that you may have in your hierarchy. And finally, we have the backends, which may be heterogeneous. So let's talk about gateway. So gateway is split into two pieces. One of them is gateway class. And gateway class really lets you specify, just like storage class, deployment-specific options. One concrete example that we've seen a lot in Ingress is some Ingress controllers merge all the configurations together and implement your Ingress configurations in one proxy. Other implementations take each Ingress definition and have a separate virtual IP and load balancer chain for them. So that kind of configuration will be attached to the gateway class. Now, the gateway represents an actual instance of a load balancer or proxy infrastructure. And this is useful because you can attach things like capacity or different permissions to various gateways. In addition, the gateway will be where you would define, say, protocol termination, SSL features, and so forth. Now, gateways need to be matched up with virtual hosts, right? And there are actually, if you think about it, there are a couple of design options here. You can have gateway reference virtual host, you can have virtual host reference gateway, and so on and so forth. It seems to make the most sense, taking from the Istio paradigm, that the virtual host attaches to the gateway. Because if you create a gateway that allows for all virtual hosts to attach to it, then you have preserved this self-service model that the original Ingress has. On the other hand, if you really want to lock it down, then you can have the gateway filter the virtual host it serves, thus preserving the operational control of the resource. Now, in terms of virtual host, again, this is like a very high-level sketch. It seems that if we go with a match action model as how to describe HTTP or L7 load balancing, it's a very generic model that lets us add more matchers and predicates later. So we can start with a very simple matcher. For example, we can just support path-based for now. And later, we can hang more predicates off of it as the cloud and portable features get implemented. And then actions, again, right now, you can start with an action that just goes sends to a backend. But again, it gives us a space to add more fancy processing later. For instance, in this case, you see an action could be reply with 404. Now, what would this look like? Again, this is just a sketch. But this is basically how the virtual host may look like, and then the kind of configuration you would write. So the bottom line to take away from this slide is what we want to do is still preserve the simplicity of the existing Ingress, but allow for future growth. OK, so in terms of extensibility, we have the in-schema extensibility, but really a lot of people also want the out-of-schema extensibility. And here, this is something we have to figure out as a community. It seems like we need a decorator pattern. Could there potentially be better API machinery to do this? Or we could decorate every single place with one of these string, raw objects, et cetera. This we really have to work out through examples and UX with the end user. Now, let's talk about portability. And here's where we're going to propose a new strategy to be pursued. In terms of portability, this is kind of a different model than Kubernetes. And the question you may ask is why? Why can't we use an existing model? So a lot of features of Kubernetes have grown up with the evolution of Kubernetes itself, for example, container runtimes. So they're easier to bring in line with a portable standard. On the other hand, we have storage classes, but they have very orthogonal features that don't necessarily conflict with each other. Proxy implementations predate Kubernetes, and they're pretty heterogeneous in terms of feature sets. What we want is a way to express in the API something that will have a gravity towards portability, towards a core API. And it turns out when we look at the way annotations are used, it's actually not very easy to corral those annotations into a core. So what we're proposing is to have an expanding ring of support. So in the center, we will have a core API. This is guaranteed portable across all providers, and really the minimal set that's required to say you are an Ingress provider. Outside of this, there's an extended API. The extended API is still portable, but only on a feature-by-feature basis. So you may support a feature in the extended API, but it must be portable. And this will be made part of the Kubernetes API schema. And finally, to catch all the other use cases, we have this custom layer on the outside. This will not be expressed in the Kubernetes API. On the other hand, you have no requirements to make it portable. So what does this give us? Well, this creates a gravity to pull things into the core. For example, if we know that, say, 80% of the implementations can support a feature in the extended API, and we generally have a sense that everyone is headed in that direction, we can put it in the extended API. We can have validations and so forth for it. And then this will standardize that usage for when the day comes, which we know is coming, and everyone's going to converge and have this functionality. So the question would be, OK, this is kind of complicated. How do we actually make this operationalized in practice? So really, you have to have enforcement by conformance tests, right? And each extended feature definition requires a contained conformance that will say, hey, your implementation satisfies this feature set. And then this is a suggestion to see if it's going to be possible is to require all extended features to be statically checkable. What I mean by statically checkable is when you submit an API YAML to me, I can look and say, oh, yeah, you have this feature enabled. I can check in an admission controller if my Ingress actually supports this. And you can create tools around it to help people migrate and be portable. So in terms of what this would look like in actuality, right, we'd expect core Ingress, and maybe we can add something like traffic splitting that's well implemented by all the controllers. In the core API, in the extended, we would have things that we see cloud providers are moving towards, but not there yet, like regex or rewrite. And finally, your extremely neat feature, of course, will never be in the core. So let's talk about future directions in terms of interesting backends, because I sketched out that we will have a resource that describes the infrastructure. Then we have a routing layer inside that describes your applications. And finally, the backends, there could be some interesting things there too. One of the things I described was the storage bucket, which you can imagine the community coming into a convergence about how to describe storage buckets. But another one that would be interesting is multi-cluster services. And here to present that, Rohit.
Thank you. Sorry. So let's take a step back a little bit and go over some use cases, right? So note that to preface this, when we talk about a global application, we mean where your backends are deployed in, say, one or more availability zones. So canary. So typically, you want to deploy your application in one locality, do whatever checks you need to do, and then roll that out across the globe. So that's one of the more simple use cases we see. And obviously, you want to serve your end users as fast as possible. And to do that, you want to ensure your backends are as close to your user as possible. So if you have a user in Australia, they get routed to backends that are closest to Australia. And something that builds off that is high availability. You want your users to be served even if the backends closest to them are down. And in general, you're OK with a trade-off in that if your backends are down, you're OK with serving your users a little bit slower, but they are being served, right? And hybrid. A very typical use case we see is teams wanting to span cloud providers for disaster recovery purposes or on-prem for compliance reasons. All right, so to kind of set the stage for what we'll be showing you, take a look at a user journey, and the kind of persona we're looking at is an admin role. And this admin wants L7 load balancing across a global service that's deployed on K8s clusters. And when we say this, we mean north-south load balancing. By this, we mean traffic that's coming in from your end users into your mesh of services. That's not to say that you need to use Istio or Linkerd. This is as opposed to east-west, which is traffic within your service mesh. And you'd want the ability to add and remove clusters to this load balancing based on your business requirements. So this gets back to the use cases of low latency and high availability. And you want teams in your organization to be able to manage their own ingress. This is kind of the self-service model. And you want there to be, obviously, a clear boundary between your admin, who's kind of controlling infrastructure, and the end users, which are your developers. And lastly, you want your teams to be able to leverage the Kubernetes API. It's a pretty powerful tool, and being able to express this in the Kubernetes API also reduces the learning curve for your developers. All right, so here's what we are proposing. From here on, if you hear me say MCI or MCS, that's referring to multi-cluster ingress and multi-cluster service. So if you take a look at what's highlighted in the red, you will see that this is very similar to the core vanilla ingress and service specification. In fact, in our proposal, what we've done is simply taken those APIs and embedded them inside the field you see called template. And the benefit of this is that this becomes very pluggable. As ingress and services evolve, we can conceivably replace their older counterparts with the newer ones in kind of a drag and drop fashion. So the new part here, which is highlighted in red, is what we refer to kind of as cluster selection. So you kind of might be wondering how this works. So this is kind of where the list of clusters implementation comes in. For those of you who are active in SIG multi-cluster, you've probably heard of the cluster registry project. And a cluster registry is really just a list of clusters. And how that's implemented is typically using a Kubernetes API server and a custom resource definition. And so how it works is you define your clusters using a CRD. They have a certain set of labels. And your multi-cluster service matches on those labels. And that's where you dictate where you want your service to live. OK, so this kind of diagram will maybe hopefully drive home the user journey I discussed earlier. So given that MCI and MCS are Kubernetes APIs, you need some place to store them. This is where the quote-unquote config source comes in. This is just a standard Kubernetes API server. And ideally, you have an administrative figure, like we discussed earlier, that maintains the API server because, after all, it's infrastructure. And you need Kubernetes clusters to run your workloads. Again, ideally, the administrative figure manages the turn up and turn down of these clusters. And side note here, nothing is precluding you from having the config source be on the same cluster as your application backends. We just separated them to make it easier to follow. And the thing that is omitted from this picture is the cluster registry. And finally, individual developers / teams, first, they manage their workloads on these individual clusters, and they manage the L7 primitives. OK, so some common questions we've gotten with this. First of all, why not have a multi-cluster deployment? On the surface, it seems like that may alleviate some of the problems of having to go in and create your deployments on each cluster. And the quick answer to that is we don't want to be opinionated on how users deploy their workloads. It's not what we're trying to deliver with this API. And furthermore, there's a lot of best practices in the multi-cluster space with how to deploy our workloads. So there's no one-size-fits-all approach there. All right, what about federation? So again, those of you who are active in the multi-cluster SIG are familiar with Federation v2. For those who are not, Federation is designed kind of to allow users to deploy their workloads across multiple clusters from a single API. Some common use cases are distributing your app with policy to multiple clusters, disaster recovery, migration. So you might be wondering how what we've proposed here is different. And the answer to that is a kind of 3 parts. The first one is that the assumptions we are making versus Federation are slightly different. One quick example is that there's a resource called federated Ingress, which, to keep it very short, is deployed in each of your clusters by the Federation control plane. In our case, we do not take that approach. And Federation is also opinionated on a lot of things, particularly cross-cluster DNS and service discovery, how you deploy your workloads. And that kind of ties into the third point, which Federation is trying to solve a lot of use cases for you. What we are trying to deliver is a more narrow offering, and I say a la carte here because that's really what it is. And so we're kind of comparing apples to oranges here, but it's important to call out. OK, and Istio. Right now, there is no reference architecture for how to do north-south load balancing using the Istio APIs. However, we do see that there is a potential for those APIs to adopt this use case. At this point, it's just a matter of waiting and seeing. All right.
OK, so in conclusion, we have 3 things. One is the initial KEP proposal about basically illustrating this sketch, we hope is coming shortly. Although we do have to get the Ingress v1 GA wrapped up first. But we'll probably have that conversation in parallel because the v2 is going to be a pretty long track, I imagine. The second thing, and I have this in bold, is that feedback from the community is key. We would love to hear what people's use cases are, what makes sense. I think we got some feedback from the contributor summit yesterday that, oh no, you're going to make me learn some more resources. Please don't make me do that. So that's always useful to know. And then finally, we expect, as part of this work, to come up with like a reference implementation so everyone can look at it, and especially the libraries for doing conformance for various controller implementers. And that's it. So thanks for coming to our talk. And this is our contact information. And we are open for questions. I don't know how this is going to repeat them. OK. OK, so two questions. One of the first one is, how do we support something like an Envoy filter? And then the second question is, there seems to be a lot of duplication. I think I may have to take that one offline. It might be hard to answer. So in terms of Envoy filter, that would be what I would expect to live in the custom land, because it's so specific to Envoy. Now, if we, for example, let's say WebAssembly filters become somehow very standardized, it may be possible to put in an extended set, but for now, I would imagine that stuff like the filters would be sort of out of scope of the portable standard. Does that answer your first question? Any other questions? Don't be shy. Someone from over here? No questions. All right. Going once, twice. OK, thank you.